Espresso Talks by Sphere Energy.
Welcome to another episode of Espresso Talks. Today I'm super excited to welcome Weihan Li, the Professor of Digitalization and Artificial Intelligence for Batteries at RWTH Aachen. You earned your PhD at RWTH Aachen.
Yes.
Summa cum laude, one must say. And you've done some impressive research along the world. You have worked with the MIT, Imperial College London, Stanford, and we just chatted, right? You have published over 110 papers or scientific publications in the field of battery modeling, simulation, or artificial intelligence. Congrats on your very impressive research, and thank you for being here.
Yeah, my pleasure to be here. I think it's fantastic what Sphere is working to bring AI and digitalization for battery testing. I think this is exactly what we need for the next 10 years.
Appreciate it. Thank you so much for being here. Weihan, why don't we start with a quick intro about yourself and your background? Maybe you can start with what initially motivated you for joining the battery field in the first place.
Yeah, I think it's not a long story. It's also not a short story. I started working on batteries and AI, I think, from 2016. It's already 10 years and we are like 2006, right? Yeah, and at that time at MIT, I finished my master thesis with Dr. Anaswamy in the direction of combining AI and physics for a better battery management system. And that is where I started working on batteries, AI, and digitalization. That's exactly what I continued working right now for the future.
Insane. I mean, given this vast experience, Weihan, I need to ask you, where do we stand currently in the battery market, in the current economical but also technological ecosystem?
Yeah, I think we are in a very interesting time period, as you have also monitored in the past 2 years, right? So in Germany, we are working very hard together with a lot of industry partners to speed up our development of battery technology from cell materials to production and also applications. And it is a very competitive market, yeah? So we have a lot of competitions from other countries out of Europe. That's why we see that it is very important to speed up, right? So in research, development, and also industry, together with all the partners.
Yeah, couldn't agree more. Speed is the key metrics here, obviously. I mean, you know, if you look at the numbers, the battery market still is booming, right? I mean, the demand for batteries, energy storage is still growing with a CAGR over 20% year over year, which are obviously impressive numbers. But the sentiment in Europe, at least, is slightly less optimistic, right? We feel that we are hitting some bottlenecks, some challenges. I would love to get your perspective on what are some of the major gaps we need to close in our industry.
Yeah, as I mentioned, so speed up. So what does that mean, right? So we need to be more efficient. Yeah, so we need to have tools with us which can help us speed up. I think for that, we do not have a lot of experience in battery production, but we would like to build this up in the near future here in Germany and Europe. We would like to have the batteries made in Germany, made in Europe, right? So very soon. That's exactly what our colleagues in industry from production lines are working together with us. But what are the advantages of being in Germany? Yeah, so to make this happen is the collaboration between the industry and academia. This is something I didn't see happening a lot in other countries, in the US and in China. We really have a very good collaboration modes between industry and academia, right? So we have different roles, but we at Aachen University are transferring a lot of technology that we are developing in the direction of AI and digitalization for battery technology in recent years. And this really helps our partners to accelerate, to speed up.
I couldn't agree more, right? Also, the way we collaborate and work together is, I think, a good example of how that synergies work in Germany. I feel already, Weihan, you want to talk a bit more about your actual field of research and our actual field of product development, which is simulation in batteries, artificial intelligence in batteries. And I mean, this is not a new field. I mean, you have been working in this field for 10 years. I would love to hear from you what are kind of some of the technological but also industrial factors that led to this growing demand, but also growing supply of simulation in the field of batteries?
Yeah. So simulation is something we have done for decades, right? So this is nothing new. What is new is the data. It is very interesting. If you look back 10 years ago when I started to work on this field, so we have simulation data. We have the data from 1 cell, 2 cells. But if you look at the data set we have right now, we have huge data set from the industry, from production lines, from testing, from the vehicles. So we helped our partners analyzing a lot of battery product data from the vehicles, applications, and others, home storage and so on. And this makes the difference because you need the AI. You must have AI right now on your hands to handle such data set. And you will find something you didn't find before with physical models. Yeah. So with such data set. So
interesting.
It is not only the model development from AI, from machine learning. It is also how the industry partner realized the importance of the data set. And this pushed a lot of development in modeling.
Yeah, I couldn't agree more. And also in the industrialization, right, which what we feel every day, right? The customers, our companies, our customers in the German and European industry, often they don't even realize the value of the data they have at hand, the value of their historic test data they have at hand that needs to be leveraged to train these AI models, so then make them again faster and more efficient in the validation and serialization of their products.
So I think 5 years ago, I think a lot of industry partners, they realized data is important. They don't have the tools yet. They don't know, okay, how should I use it?
You say 5 years ago,
for example, I'm not sure when did you
build up exactly
Sphere, right? I think at that time, the OEMs realized, okay, data is important. We need to collect them because they know that, okay, you need some years to collect very good quality data. And then at the same time, they started to build up the AI team and, the engineering team internally, in every company to be able to handle such data in the future. And now this is an exciting time point that they started to work on it, with the high quality data and the expertise in this field.
I like where you're going. Let me disagree slightly, because when we work on battery validation, right? And we collect a lot of data that we're sharing with our customers across different industries. And often what we realize is that they treat this data not in a way that it seems like they realize that there is value behind it. So I think there is still a mismatch between maybe top management or thought leaders in companies and then the actual engineers who collect the data. So I think there is still a big gap in realizing that data is valuable and then doing the hard work on actually harmonizing the data so our great AI tools can use the data.
Exactly. I think they also have different speed. Yeah, I think there are some leading companies, they realize it is important and they take actions. But there are some, they realize, okay, it's important, they start to collect, but they are very slow to do something really, important with this data set. But I think this is the role for me and for you, right? So to push them, to tell them how important it is to use it.
Absolutely. Yeah, no, exciting times, right? For sure. Before we talk more about data-driven models and AI models to solve some of the challenges in battery simulation, let's take a look at the broader spectrum of approaches, right? We have the empirical, semi-empirical approaches, ECM models. We have electrochemical models, P2D models. We have then physics-informed machine learning models, PINs, very famous these days. And then we have the pure AI models. When thinking about this broad spectrum, how do you and your research groups cluster these different models, and what are some of the advantages, disadvantages of each of those clusters?
Yeah, I think models from physics to AI, so from like a white box model to black box model, they have different, stages in development. We have worked on like ECM, equivalent circuit model, for many years, and they can be well, implemented in BMS, and they are being implemented. But for the data-driven approach, like AI models, we see a lot of application in the cloud. When we have big data set, and there we can find hidden patterns with AI models very easily. And physics is always something we would like to have. Yeah, no matter ECM or AI, we always think about how to add more physics into it. That's why people are talking about pins, right? So physics-informed machine learning. Or another strategy we have is to use AI to support the application of physics-based models to make this model be able to be implemented. For example, to solve the problems in parameterization, in simulation. For example, you have like very complex P4D models. You would like to simulate the cell design to optimize the way you do it, and it takes time. Then you can use like AI surrogate models to learn what this model tells you and to accelerate, for like more than 100 times. But you see, the future of modeling is a combination of different tools. Yeah, there's no model that is perfect for every application. We need to see, okay, what is the bottleneck for this application and what are the limitations of different models and how to combine them to achieve the goal that we are aiming for.
Yeah, absolutely right. It has to be a complementary approach between the different aspects of modeling. When we talk now a bit more about data-driven modeling, AI-based modeling, our home turf in the battery simulation, and obviously also your home turf in the battery simulation field, there are clear use cases where ECM models or other mathematical models simply make more sense, right? But there are clearly use cases where AI models make more sense. Where do you draw the line, right? Where can you say, no, for this use case, guys, I would always go with a more data-driven approach?
So I can maybe tell more from the industrial perspective. Like physics-based models, we try to push the application not only for simulation, but also for optimization. For example, when we are designing the battery cells, the diagnostics, and also the charging strategy, so we will need physical model to tell us what is really happening inside of the batteries to control the aging process. And this has been widely applied right now from research to application. We do not need to think, physics-based model is just research. No, this is happening in all the OEMs, no matter in Germany, in China, or in the US, in the top automotive OEMs. So ECMs, so this is always a very important tool, especially for pack level simulation. No matter what we have achieved in physics-based modeling. So if we go one step further for the pack simulation, ECM is still dominating. Because a lot of like thermal simulation and mechanical simulation and so on, we need to have a very fast simulation for a lot of vehicles and pack.
Let's think outside the box for a moment, Weihan. What if compute is not a bottleneck? What if compute is not a limited resource? Would you still say that ECM models are the right modeling approach for pack simulations or for BMS in general?
So if that is the case, physics-based models can also be used for pack level simulation. This is also what we are doing. For example, in my team, we are developing like Julia platform, because Julia will be much faster compared to like PyBAM models in pack level simulation. But that assumption is not correct right now, because simulation and the time, the cost is really what the OEMs care about. That's why they need some solution that can solve their problem right now.
Great insights. Thanks.
But you see that they can be used in different areas. And AI, I must say, this is something happens very fast. And right now we are working on different aspects from material level to cell level and system level, widely using AI and machine learning. Because we see a lot of gaps which we cannot, provide any solution for with the state-of-the-art models from ECM and physics-based. For example, we are having a lot of data from the lab and also from production lines as images, like camera data, like SEM, like CT data for quality control. And there we must use computer vision. We must use AI to accelerate the way we analyze this data and to extract information from it. And you are working on testing too, right? So you are using AI to accelerate the testing to make lifetime prediction. And if the data is noisy, especially for the vehicle application, for a lot of noisy battery pack data, and AI can help us to find out what are the user patterns, from different vehicle users, and then to quantify them and help us predict the future, not only the aging, but also the safety issues.
Yeah, beautiful. I couldn't agree more. And I think just to echo that, I mean, aging, batteries are such a complex system, right? And their aging obviously is often nonlinear. And I think exactly for these nonlinear behaviors, in aging of batteries, AI models can really help nowadays, as we've seen in our use cases. Now, maybe going a bit more on the technical developments, innovations, architectural innovations around AI, right? We read every day innovations around large language models, but obviously they are only so much relevant for battery simulation. There are other modalities that now get more and more relevant, modalities that we work on. You mentioned it, vision, time series, right? D-key modality of battery test data. Now, given all these innovations that are maybe less sexy than the large language model innovations, what do they mean for the field of simulation for batteries? What is now possible that simply wasn't feasible a couple of years ago, given these technological innovations?
The innovation in AI is very fast because we have some industry area that is much easier to have high quality data set, for example, from the websites, right? For example, ChatGPT. And that's why this area and this kind of data pushes the application of like LLM, right? So large language models and the others. And if we talk about the battery field, I also see a very near application of AI. That's also what we are working on. We are using it as a tool to help the engineers to design their battery systems, to help the engineers to operate their battery system. We recently have a work published to use like GPT models or others to help control the large stationary energy storage systems, considering the cell-to-cell variances and the other issues.
How did you use large language model for that, if I may ask? What data was there used to train and fine-tune the model?
Yeah, so this is a kind of tool to train our engineers. We can, fine-tune a large language model by telling it the models we have learned, the diagnosis and data set we have in our laboratory and from the field, right, to tell, okay, what could be the problem and issues, so that it is specially fine-tuned for battery application, so that we can use it to handle the very basic issues that could happen in large stationary energy storage systems. Usually we will need the engineers to charge based on their experience. So this is something that will happen very soon, right? So if we have more and more stationary energy storage system implemented in Germany and also in Europe, but also in other fields, so this is something we live with in our daily life, in our engineering system. This is the system as a assistant for our research, for our applications. There are definitely other fields of applications of AI, right? Like transfer learning, like others like, for example, unsupervised and supervised and semi-supervised or self-supervised learning. And these are not always triggered by applications in batteries, but they can easily be applied in battery fields because we have similar problems, we have similar challenges, compared to like material science and also time series data, right? So batteries, this is very similar to languages, so we need to learn what are the voices of batteries and how can we understand it and predict what they want to say in the future.
And to tie it back to your very first point of today is we need to start making sure that our data is in the right shape and quality to be able to leverage it, right?
Exactly. So as I said, the bottleneck is not the AI right now. It is more in the data quality.
Agreed.
Yeah, it's the same story for almost all industry partners. They need to be very careful about their data logging strategy for the future because this cannot be changed after you load it. And how can we guarantee that we can log the data efficiently, but with the enough quality for all the AI applications.
Yeah, agreed, absolutely. Now, Weihan, let's talk a bit about hot topics in battery simulation. I mean, this is definitely a question that I wanted to ask, that we need to ask, and while having you here, what are some of the hot topics that hasn't been published yet in one of your 110 papers out there that you can and want to talk about? Be it technological innovations, be it maybe more tangential applications or innovations. What are your personal hot topics in battery simulation?
Yeah, I think the hot topic that we are working on is actually to digitalize the way we do battery testing and quality control. I think that's also what you are working on. Because we are supporting the battery production in Germany, one of the very important steps is the formation and also end-of-line testing. That's exactly what we are trying our best to use AI and physics-based models to accelerate this whole process, to formate the batteries more intelligently and save the costs. Yeah, so from the end-of-line test and give a faster and better feedback to the production lines. So we are operating a robotic system in Aachen in our lab to automate the whole process. What we are doing there is to use robotics to automate the way we do characterizations of batteries in several hours, combining electrical tests, thermal management, thermal imaging with the camera system, and also the robotics-based CT measurement. And with this, we can accelerate, so the whole process of characterization and, gather a lot of data from the production lines to use AI to model the battery behavior to further enhance the virtual testing process.
So end-of-life simulation with end-of-line data. That's obviously a big vision and something we work towards as well. So thanks a lot for sharing. You mentioned cell manufacturing or battery manufacturing in Europe. Now let's be honest and real. Given the latest developments, rather negative developments over the last years of battery cell manufacturing in Europe, do you really think it's realistic that we in Germany participate in the value creation when it comes to cell manufacturing?
I think we can make it. The question is how. So this strategy is very important. I think based on my discussion with a lot of production players, so they need to be very fast in learning because this is something we do not have a lot of experience. And learning is something based on collaboration. Yeah, that's why we need to collaborate not only with all the partners in Germany, but also in the whole Europe and even with other countries. We know that the Asian players are dominating right now, but how can we learn from their experience and learn their story in success? This is also in some other fields what they did in past 10 years or 20 years. They learned and they accelerate and they are successful. And we need to, repeat this successful story and learn very fast and do it better, and we can make it.
Cool, I love it. Very refreshing to hear such an optimistic voice when it comes to cell manufacturing in Europe. And I agree, right? I think the key has to be ecosystems. The key has to be partnerships between industry, academia, startups, and also politics. Last question for you today, looking into a crystal ball, following your optimism, in 2 or 3 years, when we're having the same conversation again here in our podcast studio, hopefully, what would be your intro about the current market situation of batteries 3 years from now?
Yeah, I think now, after several years of bias, of development in Germany and in Europe in battery production, application, material development, I think we are now in the correct direction. We have very strong support from the government. Yeah, we have FFB, right? So in Münster, right, we are collaborating very much in digitalization, and we have partners in industry. They are very strong and they are supported by a lot of others in production. And I do think that after 2 or 3 years, if we meet again here at Sphere, we will see that we have some success in battery production and also especially in digitalization and AI. you will see, and I will see more and more players, they realize how important it is for the future, and they are taking action.
Agreed. Thank you so much for this amazing closing statement, Weihan, and thank you so much for visiting us here in Augsburg. Thank you very much to our listeners for tuning in, and looking forward to the next episode next month. Thank you, everyone, and thank you, Weihan.
Thank you.